Hey everyone, so let's combine a couple of techniques we've learned so far to create a nice little effect. Let's call it the ring of fire. And what I mean by this is those firework rings that kind of rotate really quickly and create, fireworky sparks. And this is what we want to create. And if you don't know what I'm talking about, just wait, you will see what I mean. So we start, of course, with an empty container. And what we want to start with is a circle. So this circle needs to be a polygon, and let's make sure it's actually an open arc and has a couple more points, something like this. And let's make it a bit smaller. And what we want this thing to do is we want it to rotate. So this is actually something we can do with a simple transform. Make sure you keep the circle for now at the center, because now you don't have to change anything in the transform other than the rotate. And you can't see it because my head is in the way, but the rotation would be around the Z axis. So we put in $F for now, and let's make sure we turn it on real time and run this, and you can see, okay, it rotates. Actually, I want the other direction, not rewind, but I want the other direction by inverting the F by saying minus, and then let's speed this up, let's say by 10. It doesn't look like it's fast enough. The speed is not easy to judge right now. If I lower the amount of points, you can see it's much faster than it seemed. So let's increase the number again until now it feels slower. That's just an illusion. So 10 is a pretty good number for this case. Actually, I made a mistake here. I should have used $FF here so that it calculates subframes as well. And especially with simulations and high speeds and all that, it's always better to work with $FF instead of $F. So let's put this actually in a popnet. And the cool thing about this is this will already do a lot of things for us, and that is it scatters already points on the circle. Now, what we want is that the points kind of fly off. The cool thing is all they need to have is, like in reality, just the speed of the ring. Now, what we need for that is the velocity, and the velocity is currently, by default in the pop source, already inherited. So whatever velocity we give the circle here will be inherited to the points. Now, unfortunately, there is no velocity. So if we check for v, even though it's moving. And as we've seen in the last video, we can calculate the velocity. And this is a good example where we would need that with a trail node. So let's make sure we compute velocity. And now you can actually visualize that with this button, that when I move this, you can see a little bit those bluish thingies. And also here in v, you can see they actually have velocity. Okay, great. So why do we do this? Instantly it works. So let's rewind. And you can see what happens now is that the velocity on the circle, and it looks the best when we keep the velocity visualization on, gives its speed to the points, and the points then shoot outwards. Of course, what's annoying right now is that the points keep flying outwards forever. Actually, not forever. They keep flying for, I think it was 100 seconds. So let's change that under birth in the pop source, because here you have the life expectancy of, by default, 100. Let's lower this to something smaller. You can play around, but what worked for me was half a second and then 0.25 as a life variance. And if I run this, you can see it looks like this. Now, as we've seen, it looks great when I use my velocity. It looks less great if I have my velocity not on, but this is a good indicator what we need next. Let's actually create those, streaks. And for this, again, we use the trail node, but this time afterwards and in a different way. And here you can see two use cases for the trail in one example. And what we have to do is we connect it as polygons, make sure it's not closed. And let's have a look. And it looks fine for a couple of frames. Here, this is what we want to have later on. But then it breaks here. And of course, the reason for that is that the points are dying, and therefore the point number is constantly changing, and the trail node doesn't know what to do anymore. Thankfully, we already learned how to solve this. And maybe you can remember it, maybe not. But I help you out. You first use a trail and just switch it to preserve original. Let's just make sure that the points kind of stay behind. How does it help us? Well, we can use an add node now to connect those points, but not just any points, but based on a certain attribute. And for this, we go into polygons, by group, and then we switch to by attribute, and that attribute we want to use here is ID, because the ID will stay intact even though a point dies. And here you can now see the result of that. Now we're actually quite happy in this case with the length of that, but if you wanted to have it longer, you can of course increase the trail length in the trail node. But I think 2 is pretty good here, so let's keep it at that. And now this is even closer to what we want. Great. We can stop at this point, but let's make it more interesting as well. We can use a color node, for example, to color the points in. And we want to use a ramp because what we want this to look is more like fire. And when it's born, when it's the hottest, it's white. Then it goes to orange and then red before it dies. So let's do that here. So it starts with white as a brightest. Then it goes to orange and then finally to red before it dies. Okay, great. So what do we control this ramp with? Well, for example, with the age, of course. Now we could normalize the age, but in this case we can just adjust to what we want, and I think 1 is pretty good. We could also go to 0.5 if that's what you're after. Depends on what you like more. So let's change the background actually to dark, because usually fireworks are happening in the darkness, and this looks even better. Pretty nice. Cool. Actually, by the way, you could even at the end put a black in there so that it really fades out. That would probably be the nicest. And then let me increase that to maybe 0.6, 0.7. Yeah, 0.6 wasn't too bad. Something like this. Okay, this is cool. What else can we do with this? Well, we could actually add a little bit more reality to it. For example, let's let it collide with some ground. Well, currently it is actually sticking in the middle of the ground, so let's make sure we move the whole thing up. What's important here is that you do that after you rotate your circle. Let's actually call this anim rotate or something like this, or anim rotation. So what I would do here is I create a second transform afterwards, really important, and move it up a little bit. So it looks like this. Yeah, 1 meter is fine. Why would I do this? Because I want to now, with a merge, add a ground plane to this. Let's make sure it's set to mutual, as usual, and a ground plane. And the cool thing about this is now, if you look at the result and rewind, oh shit, now we see the ground plane. That's annoying. Let's make sure in the PopNet we limit our output to pop star so that we don't see our ground, because we don't care about it really. And now, at least here you can see it collides. Well, actually, maybe I was a bit too high with this. Let's go down to 0.5. And now, yeah, and now we can see how it collides with the ground, which is kind of nice. I kind of like it. But as you can see, it bounces off the ground instantly because the bounce is still set. Okay, let's go back in. We can change it on the PopNet or the ground plane. I think ground plane makes more sense. Let's lower the bounce to 0. Let's rewind and see what we get now. And now it doesn't bounce off, but it kind of, just stays there. Cool. So the next thing I would do is add a little bit of gravity. Not too much. This would potentially break our setup, because this is by the way the default setup, so it didn't have a gravity, which in this case wasn't a big problem until now. But now I want to add a gravity to give it a little bit more of the realism that we want. And gravity is always a factor that comes in, even on fireworks. And you can see, yeah, it kind of breaks our setup because the gravity is too strong. You can adjust all the other settings. For example, you could increase the speed of the circle, but you can also, in this case, always lower the amount of gravity. Now, of course, that's not physically correct, but who cares, as long as the result is good. And then it looks like this. And you can see it a little bit that, there's a little bit of a tendency downwards. You can see it here in this area, for example, and it always gives a nice look to it. Okay, what else can we do? Well, let's add a little bit of noise to it, because if you look from the side, it's really flat. It's kind of too perfect to be believable. So let me add a little pop force to the whole thing. There we go. And let's increase the amplitude. And you can see from the side what this does. It's kind of interesting. If we go outside and maybe pin this, it's easier to see. It now kind of wobbles away, which is cool. I like that. But let's actually make it a bit stronger by lowering the swirl size and increasing the strength. And now you can see what I'm after, a little bit more chaos, which you can see down here. We could even go smaller than that. And as you can see, it changes over time, which you can't see anymore now because it's too big, but here you can see it. It changes over time. And actually, maybe this is the speed you want, you know. I don't want to tell you what you want to do with your effects. I just want to show you what you can do. But what I want to do is let me change the pose length so that the whole thing is faster. And again, that the swirl size is also smaller. And then I get quite a lot of chaos out of this. Cool. Yeah, and so I think this is the point where I stop. Well, almost. I have another idea. But this is, as you can see, nothing new. None of this stuff that we just used was new. We just combined it in an interesting way. And that was the idea behind this video, to show you what you can do with all the knowledge you have so far. So we created our sparks ourselves here, but with Houdini 19, there's actually a node that does all this for us. There's actually really a Spark trail node that does all those things internally, like a preset. So this is interesting. The time blend node is there for if you have cached this so that it can automatically interpolate the subframes. If that doesn't tell you anything, look for videos called Working with Time, where this is explained a bit further. I don't want to talk about this here. We can actually get rid of this for now because we use directly the output of the simulation, and therefore we don't need to interpolate the subframes because they already come out of it. But when we look at the result, you can see this thing creates sparks for us. And we can control this in all kinds of ways. You have a color ramp here, which you can also change because there are a couple of presets here. And you can activate color over normalized age, where it takes the age and normalizes it for us, and then takes this ramp to run over it. And on top, you can use intensity to define how bright the sparks should be when they are born. So pretty cool. Then it also uses an alpha. So when you look closely, our sparks actually use an alpha attribute, which you can use in shading to make the sparks disappear literally when they get older. Also, you can activate a split, which means when you look at the ground, you can see it best. At the end, there's a certain chance that sparks will split off, which makes the whole thing even more interesting, as you can see here, especially on the ground. And then there's other things like you can control the length. You can actually, because it basically simulates motion blur, think of it in terms of a camera. So you can change the shutter and open and close, but you can also work with the frame duration if you want. If you increase the frame duration, you should also increase the sub-steps because then the points get rounded. So keep that in mind. We will talk about this a bit more in another video later on. But for now, just play around with those settings because, you know, it's an easier way of creating those sparks. Now, I still believe you should do it by hand though, because those spark tools are kind of very specific. They are, in my experience, really just useful for sparks and not much more. Because they do a lot of stuff that only makes sense for sparks. But it's definitely a nice shortcut to, you know, create interesting effects very quickly without having to do it manually. But in my opinion, you should still understand how to do this yourself. It will help you with Houdini much more in the future. But, you know, it's a nice little shortcut for an effect like this. Another thing that students pointed out to me, and they're perfectly right, is that currently the points are accelerated in the same direction as the circle, as the rotation of the circle. Now, in reality, it's actually more like the fireworks accelerate the circle, so they shoot out in the opposite direction of the rotation of the circle. So if you want this to be a bit more accurate, how do you do that? It's actually quite simple, because all you have to do is in the PopNet, in the pop source, we have the inherited velocity set to 1, so that it gets the same speed and direction as the ring. If you want the complete opposite, of course, all you have to do really is you put in inherit velocity -1, and then the whole thing will not look massively different. But if for some reason you need a separate setup where this is correct, then just use -1 in the inherited velocity. And one last thing for you to play around even further. You know, this circle right now is rotating much faster than it seems, but it is rotating.
And the circle itself actually has an arc angle, so you can make sure that it's only, that it's only 180 degrees of the circle. And if you look at the rotation now, it looks like this, and you can imagine that potentially looks really interesting when we run this through our setup. And there we have this. So now I stop, but as you can see, there's all kinds of stuff we can do on top of this. So be creative, play around, and create your own crazy fire ring setup. But as you can see, there's so many cool things we can do with the tools we've learned so far. You just have to combine them in an interesting way. So, okay, I think I'll stop here. I hope this was helpful. Thanks very much and see you later. Cheers.